Sefficiency in Sequity is a comprehensive water management approach. It focuses on adaptation, not mitigation. The presentation is in two parts. The first part explains the concepts and terminologies needed to be able to properly develop sufficiency, which is done in this video. However, as a suggestion, it would be better if you first see the video entitled Sefficiency, Part 1 Concepts. In other words, please get acquainted with some of the terminologies and concepts that I will be utilizing in this video. To make any decision or make any kind of policy in advancing the management of a water use system, we must start with water balance. In other words, we have to know where the water goes and by how much. Some of this, at the beginning, is by estimation. However, through learning and stakeholder involvement as years go by, we can become much more accurate. Of course, if we use the issue of lack of data and do not employ water balance, there is no doubt that our solutions will be inadequate and serious water problems for our population will arise. So let us start with water balance of a water use system. The same water path types of a water use system can be arranged in two perspectives, namely, in and out. The in perspective separates the water path types into inflow and outflow, as shown in equation 1. And the out perspective separates them in terms of consumptive and non-consumptive flows in equation 2. Then, we integrate these two perspectives into one expression of water balance in a way that facilitates the development of both inflow and consumptive sufficiencies, as was explained in the concept video. In doing so, we employ the index I for inflow and C for the consumptive. Each one can be 0 or 1, and together must add up to 1. Multiplying equation 1 with I and equation 2 with C, the result will still be 0. Rearranging the terms, we get equation 3. Applying usefulness criterion S to water balance equation 3, a non-negative lambda is inserted to maintain equality as shown in equation 4. Lambda represents total water loss of a water use system and must be minimized under a proper management. However, this minimization of lambda, or the left-hand side of equation 4, is equivalent to the maximization of the ratio of the two positive brackets in equation 4 as shown in equation 5. This expression to be maximized is what is called sufficiency as shown in equation 6, and it can be defined as the ratio of useful outflow to its corresponding total inflow, which varies between 0 and 100%. If in a case the values of sufficiency goes outside these limits, it means that the data for water quantity, quality, and benefit should be revised. Taking the sufficiency in equation 6, we can write it for the three levels already discussed in the previous video about concepts. The only change needed is to substitute V1 and V2 with their equivalents according to the level. As was explained, the micro-sufficiency should be avoided. As a side note, it should be mentioned that micro-sufficiency is a kind of classical efficiency that was explained to be a flawed indicator. Besides this deficiency, many times and in many countries, various measures have been utilized on the basis that they increase classical efficiency and consequently there will be water saving. However, if the measures do not reduce water consumptions, the savings will be only paper savings according to water balance, and the myth of water saving continues. Here, sufficiency in compact forms is given, which makes it easier to see the definitions that make so much sense. The inflow sufficiency is defined as the ratio of useful outflow to useful inflow, and the consumptive sufficiency, a crucial out sufficiency, as the ratio of useful consumption to total unrecoverable flow along usefulness. One of the important issues in water management is pollution. If we take out the influence of water quality from sufficiency, we get what is called beneficial sufficiency, which can be compared to full sufficiency to understand the impact of pollution. In reality, sufficiency can be utilized to understand the trade-offs between the pillars or find impacts of not only pollution, but also between inflow and consumptive flow, and between the two levels of macro and meso. Such comparisons are powerful tools for advancing water management in a locality. Some references with free access are given here for interested parties. The third one gives a simple Excel template for those who want to test sufficiency with their own data or just with imaginary data.